Hello friends, welcome back to my channel. Today we are going to learn about the models of atom. So let's get started. First we have the Thomson's atomic model. What did it actually say? Thomson said that atom was a plum like a plum pudding, or we can say watermelon. The red part of the watermelon was the positive sphere, which had positive charge, while the seeds in the watermelon were the electrons embedded in it. So, this was what Thomson was actually saying in his model, that atom was a positive sphere in which there were some electrons embedded in it. But then we had a scientist named Rutherford. Rutherford was actually thinking of something else. He was trying some experiments, but Thompson's model was not coming in picture. So what he actually found out his own model. So how did he do so? Let's have an experiment. His experiment, what did was that he selected a gold foil because he wanted a thin a layer as possible, as thin a layer, right? So the gold foil was about 1000 atoms thick. The alpha particles was he passed. So what are the alpha particles? They are doubly charged helium ions. Since they have a mass of 4u, the fast moving alpha particles have a considerable amount of energy. It was expected that alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were much heavier than the protons, he was not expecting to see larger deflections. But results, they were actually very unexpected. So, what were the observations made by him? Most of the fast moving alpha particles passed straight through the gold foil. Some were deflected by small angles. Surprisingly, one out of every 12,000 particles appeared to be rebound. In the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. So, because of these observations, he made results. What were the results? Most of the space inside the atom is empty because most of the alpha particles pass straight through the gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atoms occupies very little space. As very small fractions of alpha particles were deflected by 180 degrees, and indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. He also calculated that the radius of the nucleus is about 10 raised to the power 5 times less than the radius of the atoms. He also gave a nuclear model of the atom that said there is a positively charged center in an atom called the nucleus. Nearly all the mass of an atom resides in the nucleus. The electrons revolve around the nucleus in circular paths. The size of the nucleus is very small as compared to the size of atom. So this was actually what Rutherford said in his model, but some of the drawbacks were still there in his model. That said that he said that electrons revolve in a circular path, so they would radiate energy, and at some point of time the energy would get finished and it would fall into the nucleus and it won't be stable as it is. So then Neil Bohr, another scientist, came into picture. What he did, he said that negatively charged electrons orbit the positively charged nucleus in circular orbits, or we can say elliptical orbits, forming electron shells. He named these shells from the center K, L, M, N, and so on. If we say number, n is equals to 1, n is equals to 2, 3, 4, and so on. He also said that electrons, while moving in these specifically type of orbits, do not radiate energy because these orbits are a special sort of called, and they are known as discrete orbits. So this was all what Bohr model of the atom said. Yes. Then J. Chadwick in the year 1932 found out that the nucleus did not only had protons, they also had neutrons, which we'll be discussing in our upcoming video.